In this experiment, we shall measure the speed of sound. We shall use the NeuLog USB Bluetooth module and 2 sound logger sensors. Connect one sound sensor to the BLT module. Turn on the BLT module by pressing the button on the module panel. Click on the NeuLog application icon to load the software and to run it. The software automatically identifies which sensors are connected to the computer. Click on the Tools button and set the ID number of the sensor to 2. Disconnect the ID2 sound from the BLT module and connect the ID1 sound to it. Connect the ID2 sensor by a 3.5 meter long USB extension cable to the ID1 sound sensor. The icons of the 2 sensors will appear on the screen. The video heat transfer experiment describes more about the NeuLog software functions. Click on each sensor icon and set the sensor range to level in dB. Click on the Run Experiment button to open the Experiment Setup Parameters window. Set the experiment duration to 150 milliseconds. Set the sampling rate to 2,000 samples per second. Set the trigger level to 75 dB for ID1 sound sensor. Press the Record button. The screen shows that the sensor is waiting for the trigger level of 75 dB. Clap your hands very close to the ID1 sensor. Sampling is done in real time when the sound is above 75 dB and saved in the sensor's memories. The samples are sent to the computer and displayed according to the communication speed. The sensor images on the left shows the participant sensors in the experiment. The graph of ID2 sensor is similar to the graph of the ID1 sensor, but in delay. The peak of each sensor depends on the direction of the sensor to the sound source. We can view the measurements before the trigger level. We can export the experiment and save it as CSV file, mail it, print the graph, or save the experiment setup. We can add cursors and move them. The X and Y values of each cursor are displayed on the left. We can select which sensor values are displayed on the left. Click on ID1 sensor image on the left and find what is its maximum value. Move the left cursor to this point. Click on ID2 sensor image on the left and find what is its maximum value. Move the right cursor to this point. On the left, you can see delta X, which is the time difference between these 2 maximums. In our experiment, delta X is 10 milliseconds. The distance between the sensors is 3.5 meters. Velocity is equal to distance divided by time. The speed here is equal to 350 meters per second. The accurate speed of sound in air is 343 meters per second. Challenge: use longer USB extension cable and check if you get better results.